Hello everyone, this is Mehdi and this is the first asynchronous lecture of Operations 1 2020. This video is about Excel Solver. Excel Solver is a tool based on Excel which we are going to use quite a lot during the courses Operations 1 and Operations 2. Excel Solver solves the optimization problems. Optimization problems are a sort of mathematical formulation of decision making and planning. We have lots of such problems in analysis of supply chains and logistics problems. I'm going to explain you what I mean by decision making and planning through an example, and then we are gonna learn the basics, the very basic functions of Excel Solver through a simple example. Later on through the course, you're gonna learn more advanced functions of Excel Solver and how to interpret its results, but that's just the start point. To begin with, I would like you to open this file. Please download this Excel file, namely Asynchronous Lecture 1 Excel Solver 01 Initial from its learning, and open it and then do whatever I am doing with me. Once you have opened this file, let me raise this. I assume that you do not have Excel Solver add-ins on your add-in on your Excel. So first we are gonna install that. Please go to the File menu and then go to Options and then select Add-ins, and then at the bottom of the window you see Manage Excel Add-ins, press Go, and then you see a list of add-ins that you can add to your Excel. The name of these add-ins are in Norwegian in my Excel, but if you're gonna use an English version, you will see the names like this. This problem löser is gonna be solver, and the other tool that we are gonna use is the first one. It's the analysis tool. Okay, so I would like you to select these two tools. We are gonna learn actually only about Solver in this video, not about this analysis tool, but later on through the course we will require that. So yeah, I would like you to install both of them at the same time. Select these two and then press OK. I am using Excel on Windows here. If you're using Mac, perhaps you have to go through a little bit different steps, but it's quite similar. So once you have installed these two add-ins, if you go to Data menu, you will see two new buttons here. So in the analysis part, you will see Solver and Data Analysis. So, yeah, now let's talk about what I mean by optimization of decision making. Here is an example. We have a decision-making problem here. Let me explain it to you. Assume that In this semester, you have taken 4 courses, namely Supply Chain Management, Operations 1, Distribution, and Risk Management. Of course, you're not going to take these 4 courses at the same time. And actually, I have assumed that the ECTS points of each of these courses are 4, 4, 3, and 3. In practice, we know that the ECTS number of supply chain management operations, all of these courses are different. Yeah. But assume it is like that. Then it is at the end of semester. And you have 2 weeks available time to prepare for the exams. So you have limited time, and you have to divide that limited time among these 4 courses. Your question is how many hours you should study each course. Yeah? So let me add one more column such that we can enter our answers to that question, our decisions. Let me see, hours assigned to the course. Yeah. So again, we assume that each day of these 2 weeks, we can spend at most 9 hours to be prepared for the exams. So in total, our available time in terms of weeks is 2 weeks. But if I want to calculate it in terms of hours, it would be something like that. I'm going to type a formula in this cell. So this is 2 weeks times each week is 7 days times each day is 9 hours. Yeah, 126 hours is the total available time that we have. And we want to know how much of these 126 hours we should assign to each course. Yeah, therefore, for example, I can say 30 hours to supply chain management, 40 hours to operations 1, 20 hours to distribution, and let's say 20 hours to risk management. I can calculate the sum of hours assigned to all of these courses. So total hours spent is sum of these numbers, and you see that we have spent 110 hours according to the numbers I entered here. However, we have 126 hours available. Therefore, I can, spend a little bit more. So I can, let's say, give it 26 hours here and 30 hours here, for example. And then I have spent all of 126 hours available that I have. But then the question is, the decision that I have to make is actually here. How many hours should be assigned to each course? This part, the answer that I give to my question, this is actually the decision. These numbers are my decisions that I am making. Sometimes we call these numbers a solution. So this is one solution, for example, and let's say, for example, 20 20, 50, 20, 36. This is another solution for the same problem. Okay, so in this problem we have unlimited number of different solutions, different answers to our questions. But which solution is best? First, we have to define what best means. Assume that we want to maximize our GPA, at the end of semester. So let's calculate GPA. In order to calculate GPA, let me assign one cell to the GPA. So for example, here, GPA. And let me color these two in blue. In order to calculate GPA, I must have the points or the grades that I receive for each course in addition to the ECTS. Assume that each course could have a score, number of points between 0 and 100. So 100 is the maximum possible points for each course. And also we require 35 points to pass each course. Anyways, I do not have any points, any score for each course. How could I calculate the score of each course before I take the exams? Here we have to kind of predict what will happen if we spend, let's say, 10 hours for operations 1. What is the score, the final score that we can expect? A student, based on his or her previous performance, have estimated these numbers that you see in this column. Points expected per hour of study. So she, for example, assumes that if I spend 2 hours for supply chain management, I will receive 1 point out of if I spend 1 hour for supply chain management, I will receive 2 points of that maximum 100 points. Therefore, if I spend 2 hours, I will have 4 points. If I spend 10 hours, I will have 20 points. If I want to have the full score, 100, I have to spend 50 hours studying supply chain management. But does it worth it? If I give all of so much time to supply chain management and do not spend any time to operations 1, distribution, and so on and so forth? We do not know. Anyways, this student has estimated these numbers. So how many points will she achieve by studying 1 hour of each of these courses? Then we can calculate another number. Expected score. If we have a solution to our decision-making problem, so we have a number of hours assigned to each course, and we know these numbers, then we can calculate an expected score for each course. How? So 20 hours is assigned to supply chain management, and each hour gives us 2 points. So in total, we can expect a score of 40. Then actually you can copy this formula to the rest of the range by moving your cursor, your mouse pointer, to the bottom right corner of that cell. When it turns into a black cross, then you click, hold, and drag down, and then the formula is copied for the rest of the range. Therefore, for example, this 75, where does it come from? It is E3 times C3, or 50 hours times 1.5 points per hour. Okay, so these are the scores that we can expect. Based on these scores, then we can calculate the GPA. How we can calculate the GPA? GPA could be calculated as follows. So the score of the course times ECTS number plus the score of the next course times its ECTS number. So sum of scores times ECTS numbers divided by sum of ECTS numbers. This is how we calculate GPA. Yeah. So I can let me first write the formula in the in an extended format. Then I will give you a better formula for that. So this score for supply chain management times ECTS of supply chain management plus score of operations 1 times ECTS of operations 1 plus score of distribution times ECTS of distribution plus score of risk management times ECTS of risk management. Then the total divided by sum of ECTS numbers. That will give us the GPA, 61 almost. And yeah, then let me write this formula in another way. I want to write an equivalent to this part of the formula where I multiplied the elements of column F to elements of column B and then found the sum. If I want to do so, it is enough to use the function, namely sum product. This function in Norwegian is, if you are using Norwegian Excel, is summer product. I will upload later a file that gives you the Norwegian equivalents of the English Excel functions that I am using here, in case you are using a Norwegian Excel. So sum product of, in sum product, you can use multiple ranges of Excel. So sum product of, for example, this range, expected scores, and their corresponding ECTS numbers. What does it mean? It means, okay, hey, function sum product, you have two ranges, F2 to F5 and B2 to B5. Multiply the first element of this range into the first element of this range, then the second element into the second element, third element into the third element, and so on. And then find the sum of these products. This is exactly what we did. So if I press enter, we will have the same result as before. As you see, 61. Before I continue, there is something else that I have to emphasize here. Please look on the separator of arguments that I used here. Look here. This function sum product requires two or more ranges. These ranges are separated by symbol semicolon. This is because the format of numbers in my Windows is Norwegian. In case you have such settings in your Windows, yes, in formulas of Excel, you have to separate your arguments by semicolon. But if you are using an all English Windows and Excel and the format of numbers and everything is English, then the arguments, the different parts of a formula are separated by comma. Yeah, that is a difference. So just be aware of what I am doing here. Yes. So now we can compare different solutions. So that is one solution. Let me see if I assign different hours to the courses. So instead of giving 20 hours to supply chain management and 50 hours to operations 1, I want to give 40 hours to supply chain management and 30 hours to operations 1. Still, total hours spent is not exceeding the total available time. But look at GPA. GPA is higher than before. Therefore, that solution is better than the previous solution. That is what we are doing in optimization. Optimization means finding the best, the optimal solution to a decision-making problem. Finding the solution, the decisions that give us the best score, the best GPA. So best here means highest or maximum GPA. Okay, let me review what we did. We have a sort of decisions to make, or we have a solution to find. Based on this solution, we can calculate something, some criterion that should be maximized or minimized, something like this. We want to maximize our GPA. Yeah? Then what solution gives us the maximum GPA? This is an optimization problem. And this is what Solver in Excel does for us. Okay? Now, I want to use Excel Solver to find for me the best solution. So let us do it. You can leave these numbers as they are here, and then Solver changes them such that the solution becomes better. But also you can, if you do not want to be distracted, you can delete these numbers and let the Solver fill it. But yeah, let's go to Solver. First, you must go to Data and then to Solver. Oh, I actually made that model before. So before starting, please press that button, Reset All, such that the existing model is erased. Yeah. So the first thing that you have to specify in Solver is to set objective. What is the objective? Objective is that criterion I told you. In this case, GPA is our objective. Objective is something that normally we want to minimize or maximize. We want to optimize the objective. Sometimes the objective is the, for example, cost of production in a factory. So we want to minimize it. Sometimes the objective could be the revenue of sales. So we want to maximize it. And that becomes our objective. Anyways, you have to specify one cell here for this set objective. Therefore, I click on this box and then go click on the cell at which I calculated my GPA. And then you have to tell Solver what you want to do with that cell. Do you want to maximize it? Do you want to minimize it? Or do you want it to be exactly at a specific value? We want to maximize our GPA. Okay. Then by what means you want to maximize your GPA? I want to maximize my GPA by assigning hours of study to these 4 courses. I want to find the best assignment of hours to these courses. So solver asks this question like this: by changing variable cells. So which cells are those you want to change their values to maximize your GPA? These yellow cells. So I click here first, and then I select this range. So I want to change the values of these 4 cells and find the best values that maximize my GPA. Yeah? Okay. Then let's just run solver like that. We are going to change it later. But just let me explain one more thing in solver. Here you see a box that you can check or uncheck. Make unconstrained variables non-negative. You can check it or uncheck it. By default, it is checked. What does it mean? It means that, okay, you have 4 cells as variable cells, as stated here. Do you want the values of all these cells to be non-negative? In our case, yes, because we cannot, for example, spend -2 hours to supply chain management. All of these hours must be positive. Okay, so this is logical. So I leave that check mark to be here. That selected solving method, we do not discuss that much about it. That's what it is, but please select simplex LP. I will explain about that later in the course. Just select the method as simplex LP and press the key solve. Okay, here we receive it is not an error message, but a warning. It says that the objective cell values do not converge. And it continues like that. Solver can make the objective cell as large or as small when minimizing as it wants. What does it mean? Let me close that. It means that, okay, I am just a robot. I do not understand, the context of the problem in human language you are talking about. So you told me to maximize this formula, this cell, this objective cell. Yeah? How? By changing the values of these guys, these cells, and all of them must be non-negative. Okay? You want to maximize this? Let me try one solution. I spend 1,000 hours for this course, 2,000 hours for this one, 5,000 hours for this one, 300 hours for this one, and the GPA is 4,000 something. Wow, quite impressive. Okay, I want to make it better. I spend 10,000 hours here. The GPA is even more. Okay, I make this one 1 million. The GPA is even higher. So it means that this robot, this solver, can make GPA as high as it wants. It has no limit, because it can give, high numbers to these cells and have GPA as high as possible. So what should we do? What have we done wrong? We know that we have limited hours of study, at max 126 hours. So it is not possible to spend in total 1 million something hours for studying these courses. Yeah? We as human beings understand it, but this machine, no. We have to tell it. We have to formulate it for that. So something is missing in Excel, and we want to talk about it. This thing that we want to talk about it is called a constraint. Constraint means limitation. So what I want to talk about is the constraint of limited hours. How can we define it mathematically for Excel? Here we calculate total number of hours spent for study, and here we have the total available hours for study. Let's name it A and this one B. If I want to write it mathematically, A should be always less than or equal to B. And this is how we are going to define it for solver. Okay, so we have two cells, and I want to tell solver that one of the cells have to be always less than or equal to the other one. So we go again to solver, open solver, and you see another section in solver, subject to the constraints. You can add as many constraints as you want to an optimization problem, but here we start with only one, the constraint of limited study hours. So press add. Each constraint consists of three parts. Solver calls it cell reference, sign, and constraint. In the optimization terminology, sometimes we call it left-hand side, sign, and right-hand side. Yeah, so these are quite equivalent. But so we want to tell that total hours spent. So I click here and then here. Total hours spent. And here you can choose a sign, less than or equal to. What is the limit? 126, which is given in this cell. I could have entered this number, manually here, but I would prefer to use the number that exists in this cell such that I can, change it later, and solver calculates the answer automatically. And then press OK. And you see that now we have a constraint for our solver. Now press solve. Okay, we didn't receive that message again. Let it be at keep solver solution and do not select any of these reports. Just press OK. And now you see some solution here. It is quite a strange solution. What is it? It says that spend all of the hours that you have. We have 126 hours. Spend all of the hours for distribution, and your expected score would be 378. I know it is impossible. But based on that, when you put it in the GPA formula, you have a GPA of 81, which is very good. If you spend those hours to any other course, you would have a smaller GPA. Why? Because distribution, as you see, has a high output rate. If you spend 1 hour for distribution, you will receive 3 points, which is higher than other courses. But there is some problem. This solution is not acceptable. We call it, when a solution is not acceptable, we call it infeasible. Why it is infeasible? Why it is not acceptable? Because we cannot receive a score higher than 100 for each course. Yeah? So we have to do something about it. Until now, we had only one constraint, and that constraint was total number of hours available. Now we have, I think, another constraint. What is the constraint? The other constraint is that, let me show it here. These expected scores, let's name it again A, and this maximum number of points, let's call it B. Again, we have something like that. A must always be less than or equal to B. The score that we expect cannot exceed 100. So, by spending 33 hours for, let me just type it here. By spending 33.33 hours for distribution, we will achieve that, again, decimal places in Norwegian are typed as a comma. If you have English setting for the numbers on your Windows, you have to type point. But anyways, if you spend 33.33 hours for distribution, your score will be 100, and you cannot achieve higher scores. Therefore, there is no point for studying more than that for distribution. You have to spend the rest of the hours that you have for other courses. Okay? Now we want to enter that constraint into Solver. Let's see how we do it. So go to Solver and open it again. You have to go to constraints and add a new constraint. How? So there are several ways. I do it in the difficult way first, and then we'll show it a more easy way. So for example, expected score of supply chain management must be less than or equal to 100, which is the maximum number of points. Press add, such that you can add another constraint later. Expected score of operations 1 cannot exceed the same number, 100, add. Expected score of distribution cannot exceed the same number, add. And expected score of risk management cannot exceed 100. And then press OK. Now look at here, we have 4 more constraints here. And if I run, of course, these constraints will be taken into account. But instead of these 4 lines or 4 constraints that I entered, I could have entered only 1 line to make it easier. Let me delete these 4 constraints that I just added to Solver. So you can click on any constraint you want here and press delete. Okay. You can select actually multiple constraints to be deleted. Okay, now the only constraint which is remaining is the first one. Total hours spent cannot exceed 126. But let's then add another constraint. I can select these 4 cells together. So see here, instead of one cell, I have 4 cells. I have a range. Should be less than or equal to, I can type 100, or if I want to refer to a cell, I can use this number and press OK. Now all of these 4 constraints are kind of combined into one. Now, If you press solve, and press OK, now you have other, solutions, other number of hours for the courses. So you see that you have spent the maximum possible number of hours for supply chain management and distribution to receive full score, and the rest of hours for risk management, then you have again received a high score. But as for operations one, Excel suggested you not to spend any hours, because the outcome of your study hours is not that high in operations one. You have to study a lot in order to receive 1 point. And this is the maximum possible GPA. You can try it for yourself. You can give any solution that you want here which satisfies these two constraints we just discussed, and you cannot achieve higher GPA. But still, there is a problem. We do not want to fail any of these courses. The minimum points required for passing a course is 35. Now, I want to give you an exercise. I want you to change the model in Solver such that the expected score of all of the courses are higher than 35. Okay? So in other words, we want to add another constraint. Please do that exercise for yourself, and later on I will publish the solution on its learning. Thank you for listening, and see you later.